1.
Alright, for this week, my dear friends, we have experiment 2, which is spring constant. So, the aim of this week's experiment is to verify Hooke's law and to determine the spring constant. Now, Hooke's law, what is Hooke's law? Hooke's law is F is equal to minus Kx. F being the force applied on the spring, K is going to be the constant of the spring, and X will be the displacement. We will be working with just weights. If we move to our very nice materials and apparatus here, we will be working with these weights. And the spring, the cork pad, the clamp, we have our tall stand here, we have our meter stick which has pointers for reference. Alright, these are your apparatus. And remember, we are using 3 metallic weights, 50 grams, 100 grams, and 200. As we will see later on, we use also 150. How do we find the 150? We just combine the 100 and the 50 together. Now, for the spring constant, if we can see here carefully, when we place a weight, the weight will pull the spring down, so it will displace it. Our job is to measure how much it has been displaced, and we shall put this displacement in our table, and from that we will find the spring constant. As we see on the board here, we saw a moment ago that we just put the mass. So it means by putting the mass, we just have the gravitational force which is acting. So it means the force here, the applied force, will be mg. So now mg will be equal to minus kx, which means k here will be mg minus mg over x. This is your spring constant. If we move and see our tables here, we will explain in a bit how we got these numbers in the table. We used all of these numbers to unite your reports. So basically these are the numbers you will be using in your report. Please watch them, look at them carefully. If you still have any question, don't worry, you can email me, I'll send you this again. As for the displacement here, so firstly, if you notice the table, you will see that it's original spring length. We will see what that means. And the spring length, we will see also what that means. If we move back to our apparatus, basically what we are doing is, first we have this original spring. We have the spring here. We will put the pointers for reference on the top of the spring and on the bottom of the spring. Okay, we try as much as we can to fit it between our pointers, and we read the numbers. So here it's 18.67, it's 18.7 minus 10.3. So this difference here is your original spring length. We can take an example. If we have something up here and something down here, the length between them is the height here minus the height here. Same way when we are reading from this toe stick. You see the numbers and you minus them. That's how we get the original length, and you put it. You say our original length is 8.1. So this 8.1 came from minusing these two numbers. The spring length came from after we put the first, we start off with the 50 grams, and we measure again from the top point to, please pay attention, we measure to where the spring is, not to where the mass is, because we're interested in the spring displacement, not the mass. And if you take the measurement of the mass, you have more error, and it's wrong. So now our spring length is going to be 23.1 in this case minus 10.2. And so on. After the 50, you take off the 50, you put 100. Same procedure. You take the measurement, you put it on the board. Then for the 150, you just add the 50, measure again, record. You take off the 150, you put the 200, same thing, measure, record. Please pay very good attention because again, for the length, we do the difference of these two. That's how we got our tables, these two tables. There were two groups next to each other. Group 1 was using this first spring. Group 2 was using a second spring. Why? Because for the spring constant, it changes if you're using, first of all, a different spring. So this constant changes from one spring to another. And the second one is, if you apply too much force on the spring, it gets broken. It means this law is no longer valid because the constant is no longer valid because the spring is broken. These are the two cases where K is not a constant. Anywhere else, the K is constant for each spring. Now, what is your job? Your job when you're doing the report right now is, first of all, you need to fill the displacement. You need to calculate this and put it in the table. How do you calculate the displacement? Again, displacement is being displaced from your original location. Alright? So you're going to do spring length minus the original length and you get your displacement. So how much the spring moved from its original length? This is the displacement x. This is your x here. Okay? This is for concerning your table part. So for your table part, you fill these here and you put them in a table. This table 1, and you'll have a table 2 in your report. So in your report, you will have 2 tables. Yes, not one table, 2 tables. And for the graph part also, you will have 2 graphs. First graph, m versus x, depending on the first table. Second graph would be m versus x as well, depending on the second table. Yes? Why we do that? To show you the differences between 2 spring constants and 2 springs. Yes? So in your calculation part right now, for each line here, you have your mass and you have your x, and we unify g as 9.81. Okay? So you will use for every line here, you will use the mass, displacement, and g to get the k. So you will have K1, K2, K3, K4, K5, K6, K7, K8. So you will have in your calculation 8 Ks. What do we expect? We expect that for the first tables, the Ks to be very similar. For the second table, the Ks to be very similar because these are 2 different spring constants. And we expect that these Ks are different from these Ks. We expect that. But you will see from your calculations and from your report. At the end, the later comments, I want to comment very well. So please see your original videos in case you forgot how to do the report. Check out the first video, which is about report writing. If you have missed the first quiz and the first report, fear not, you have at the end of the semester a makeup for these. But there is no makeup for the quizzes. There is just makeup for the report. For the quizzes, if you missed it, you missed it. At the end of this week, either Friday or Saturday or Sunday, there will be a quiz. Please keep checking your Moodle to see what time is the quiz. Post it throughout the week, and hopefully your reports will be corrected throughout the week as well. Some final comments. In this week's report, so from now until next week, I expect a couple of things. First thing, in the procedure part of your report, you should mention that you are using 3 metallic weights. Yes? Of course, we have used 4 mass here. Why? How did we use this one, the 150? By combining these 3. Yes? So we expect you to say that there are 3 metallic balls. We're using 3 metallic masses. You should state that in your lab report. It means if you don't state that, I will put you 0 in the procedure. That's number 1. Number 2, you should mention when you're writing Hooke's law, just mention this equation as well and tell me what is K, what is M, what is G, and what is X. You should do that as well, or else I will not put you a grade for your equations. And I expect, as I said, these 2 tables in the report and 2 graphs as well. Your calculations, we expect 4 Ks. Please write it in clear English, even if you're onward, just clear English. This is what you have to do until next week. Hopefully you will do it correctly. Thank you very much. If any questions, please send me an email or web mail.